It's really an amazing little critter, and it's been around for over 3 billion years. In 2016, Utah Lake exploded and cyanobacteria blooms. The problem is that many cyanobacteria produce toxins.
You may have heard it called blue-green algae, but it's really a kind of bacteria taking in sunlight to drive photosynthesis and giving off oxygen.
It actually requires quite a bit of lab testing to know whether or not it's a harmful algal bloom. And what we're really worried about is people and pets ingesting that cyanobacteria.
Dr. Kate Fickus is a harmful algal bloom scientist at Utah State University. She helps the Utah Department of Environmental Quality track conditions in lakes and reservoirs.
So Utah is the second driest state of the nation. Most of our major lakes are actually man-made reservoirs. They're heavily used for recreation. They're heavily used for agriculture. And they're really important to the state as a resource.
In 2017, harmful algal blooms returned to Utah Lake. This time, officials used satellite data to identify troubled locations. But how can instruments up in space tell us about microscopic organisms in a lake down on Earth? By measuring their blue-green color. Landsat collects light in visible and infrared wavelengths. Cyanobacteria reflect more green light than plain water does, allowing Landsat to identify algal blooms.
From satellite, what we see is basically that primary pigment, which is chlorophyll A, but the color by itself could be misleading. A nice picture is not necessarily providing a set of quantitative data.
Algal blooms can look beautiful from space, but the numbers behind the images are the important part.
Each measurement is highly accurate, and it's very much corresponding to the number of photons that are leaving the body of water, which could be related to the biomass and the amount of phytoplankton.
Dr. Nima Pahlavan is working with NASA and the U.S. Geological Survey to make sure Landsat users have consistent, accurate, and ready-to-use data about lakes and rivers. Water is difficult to study from space because only a fraction of the sunlight is reflected back to the satellite. But engineering improvements on Landsat 8 have leveled up its ability to measure the small signals from water bodies. After Landsat collects the data, it gets beamed down to the USGS AROS Center, where it is archived. The raw numbers pass through checkpoints to align the geography, correct for sun strength, and then compensate for the effects of the atmosphere.
So you essentially removing those atmospheric scattering and absorption.
Let's break down what NEMA means here. To measure the amount of cyanobacteria, you need to know how much light reflected off the surface. But some of that light gets scattered by molecules in the atmosphere on the way to the satellite, lessening the signal received. And sometimes light that never made it to the surface gets scattered into the satellite, adding a false signal. Like removing the haze from a photograph. Atmospheric corrections leave you with a quantitative measurement of exactly how much light left the water, known as aquatic reflectance.
You want to look at the actual physical measurements to derive physically meaningful products from satellite data.
And that's the goal, to transform the raw materials into finished products so that end users don't have to build it themselves.
By providing aquatic reflectance products, you're majorly reducing the burden on satellite users.
Although it is still provisional, NEMA's aquatic reflectance data product is available for download from the USGS. Scientists like Kate Fickus convert the data product to maps showing the amount of chlorophyll A, helping local officials pinpoint where to test for toxins and warn residents.
I use Landsat and other remote sensing technology to help local health departments understand where there's a bloom, the magnitude of the bloom, and the size of the bloom.
The spatial detail is another benefit of using Landsat data. Each pixel is only a 30-meter square, the size of a baseball diamond. Yet it collects data across a broad area. In other words, there is a lot of data at a fairly high resolution.
With Landsat, we can get into some of the marinas that are popular fishing and swimming spots in order to inform local health departments about making public health decisions.
For the 2017 outbreak, that's exactly what happened. Satellite data gave an early warning to local officials in Utah. The extra week of warning saved hundreds of thousands of dollars in healthcare costs. Monitoring algal blooms from aquatic reflectance data is just one example of benefits from Landsat's data products. Wildfires, snow cover, vegetation health, temperature, and more are available for every spot on Earth. Landsat's highly calibrated data products, free to download and use, are making detailed Earth observation data more accessible to users and bringing a greater benefit to society.